Now let us see the next bit of this chapter. It is a concept of work zero and machine zero. Both are very important to write a part program in the machine. So this is a diagram of a lathe machine. Here you can see this diagram. Work 0 it is shown and machine 0 it is shown here. Now let us understand what is the work 0 and machine 0. I have shown this diagram by zooming it to just understand what is the location of work 0 and what is location of machine 0. Now you see here machine 0 is a floating point in a space having a measure normally to accommodate a length of machine and maximum transverse length to each axis. So machine 0 it is not a fixed point. You can see this diagram. Machine 0 is not a fixed point. It is shown at a location here, but it may be at another location in a machine. So it is not a fixed point. But if you see a work 0 normally sets at a front face and at the center of a job. So you can see this diagram. Work 0 it is normally set at front face and center of the workpiece. So while writing a part program, we take offset in a machine, in a CNC machine we take offset, and this offset is taken with respect to a work 0 and we write a part program. So once again I repeat, what is a machine 0? Machine 0 is a floating point in a space having a measure normally to accommodate a length of machine and maximum transverse length to each axis. So machine 0 it is not a fixed point, it is a floating point and it may be at any place in a machine. And work 0 it is normally set at front face and at center of the job. So work 0 is important to write a part program. Sometimes in examination we are asked to write a part program, but their work 0 is not defined, so we have to assume this work 0. So work 0 you can take at the front face at the center of the job, or you can take at any space on the work. So work 0 you must assume on the surface of workpiece itself. So work 0 is important to write a part program. It is a reference positions to define a coordinate in a part program. Now let us see a types of NC system, that is a classification of NC system. First one is it is based on motion type, point to point NC system, then straight cut NC system, then contouring NC system. Next is the based on positioning system, incremental NC system, absolute NC system. Then on the basis of control system, open loop control system and closed loop control system. And next one depends on power supply, electric power supply, hydraulic power supply or pneumatic power supply. So let us understand these types of NC system one by one. So first one is a point to point NC system, PTP. So in this point to point NC system, so coordinates or workpiece moves from one point to another point in a linear motion. You can see this diagram. So these points indicates motion flow, motion direction of workpiece. Each point has coordinates and tool moves from one point to another point to third to fourth to fifth. So these points are nothing but you can call it as a holes which are which are obtained by using a drilling tool, and this drilling tool drills the workpiece is mounted on the table. So tool moves from point to point. So whenever you go for the drilling operation, you need a point to point NC system, one example I will tell you, convex drilling it needs a point to point NC system. Now let us see a straight cut ENC system. Straight cut ENC system is mostly used for milling operations. You can see this figure. In this figure, this is a milling tool, and there is a workpiece which is to be milled, and this spindle moves along the surface of the workpiece, and you can mill the component. So you can see here the direction of milling tool, direction of milling tool in which it moves, that is shown in this diagram. So this tool moves from this location to this location in a direction of C section. So milling operation will happen from straight cut NC system because tool is going to move in a straight direction along the surface of workpiece. Now let us see a contouring system. A contouring system, it is a very useful system as per the desired path, as per the will of a manufacturer or a user. You can move the tool in any direction. Suppose I want to move the tool in straight direction, you can move. You want to move the tool in a circular direction, you can move. If you want to move the tool from point to point also, you can move. So desired cutter path that you can obtain by using a contouring system. A special contour you have to define for milling or a drilling operation. So contour system is used for both. Here in the diagram I have shown here, only a milling operation is shown in this diagram, but it can be also used for a drilling operation or a slotting operation. For both operation, if you want to create a slot in a particular contour direction or in a desired path, you can use this contouring system option. Now let us see the next type, incremental and absolute positioning system. So both are very important for writing a part program. Mostly we write a part program in absolute positioning system. So what is the difference in between these two, absolute system and incremental system? Let us understand this. So here one table I have shown here. In the table there is a absolute system coordinates, and there are incremental system. These are the increment system coordinates, and these are the absolute system coordinates, and these are the whole positions A, B, C, which are shown in this diagram. This is the position of A, this is position of B, and this is position of C. Now what happens actually in the absolute coordinate system? Suppose this is a origin I have shown here. With respect to origin, coordinates of point A is written. With respect to origin, coordinates of point B is written. Similarly, with respect to origin, coordinates of point C are written. This happens in absolute coordinate system, but in incremental coordinate system, if you write a coordinates of point A with respect to origin, but while writing coordinates of point B, you should write the coordinates of point B with respect to point A. Means next point, while writing coordinates of next point, previous point should be a origin. Suppose in this diagram you want to write coordinates of point C, point B should be a origin. So previous point becomes origin, and you can write the coordinates of next point. This is called as a incremental coordinate system. Both coordinate system mostly used for drilling operations only. You can see the difference exactly. In incremental coordinate system, x coordinate, y coordinates are written with respect to by assuming previous point as a origin. Now let us see absolute coordinate system. What are the advantages of absolute coordinate system, ACS? It is a very easy to check and correct a program written.